Standard 9, Subject Science and Technology. Lesson number 11, Reflection of Light. Now let us see drawing the reflected rays. In the given diagram, M1 is a spherical mirror and ray AQ is incident on it. CQ is a radius and therefore is perpendicular to the mirror at Q. Thus, angle AQC is the angle of incidence. Angle AQC is the angle of incidence, and according to the law of reflection, angle of incidence and angle of reflection are of the same measure. Thus, while drawing the reflected ray QB, angle CQB must be equal to the angle AQC. To draw a ray diagram, we use the following rules, which are based on the law of reflection of light. The diagram is given below. Rule 1. If an incident ray is parallel to the principal axis, then the reflected ray passes through the principal focus. Rule 2. If an incident ray passes through the principal focus of the mirror, the reflected ray is parallel to the principal axis. Rule number 3. If an incident ray passes through the center of curvature of the mirror, the reflected ray traces the same path back. Let us see image formed by concave mirror. In this diagram, an object AB is placed between the focus and the center of curvature of the concave mirror M1. The incident ray AQ is starting from A and going through the focus F becomes parallel to the principal axis after reflection and returns along QR. The incident ray AS parallel to the axis after reflection passes through the focus and returns along the path ST. It cuts the reflected ray QR at point A dash. Thus, the image of A is formed at A dash. The point B is situated on the principal axis, and so its image will also be on the axis and will be directly above A dash. Thus, the image of B is at B dash. The image of points between A dash and B dash will be formed between point A dash and B dash. Thus, the image of object AB is A dash and B dash. From this, we see that when the object is placed between the focus and center of curvature of the mirror, the image is formed beyond the center of curvature. This image is larger than the object and is inverted. As the reflected rays actually cross each other, the image is a real image and can be obtained on a screen. Let us see in this image an object AB is placed between the pole and focus of mirror. The incident ray AQ is parallel to the principal axis and the incident ray AS is in the directing joining A with the center of curvature. The figure shows how these rays get reflected and form the image A dash B dash of the object. This image is behind the mirror, erect and larger than the object. As the reflected rays do not actually meet but appear to come together behind the mirror, the image is a virtual image. Now let us see image formed by a convex mirror. An object AB kept in front of the convex mirror M1. Incident rays AQ is starting from A and traveling parallel to the axis, and AR going toward the center of curvature are shown in this figure. How these get reflected and form the image A dash B dash can be understood from the given figure. It is clear that the image is smaller than the object behind the mirror and erect. As the reflected ray do not actually cross one another, the image is a virtual image. The nature of the image formed by a convex mirror does not depend on the distance of the object from the mirror. These images are always virtual, smaller than object, and situated behind the mirror. Thank you.